Hi Geometry, this is Unit 4, Lesson 6, page 471 of our workbooks. You are asked to find the value of z. You have two angles given to you, the 40 degree and the 50, and you could use either one. So I'd like you to pause this video and calculate z, and then come back and see how you did. Welcome back, Geometry. I hope that you got 4.67 for the length of z, but what I'd like you to notice is I showed my work using the 40 degree angle in red and finding the 50 degree angle in green. You can see no matter which angle I used, I could find the same answer for the length of z. This gives us lots of options when solving our right triangles with trigonometry. This is the same triangle you and I were just working on the page before. So it says to use our calculator to determine the values of cosine 50, sine of 50, and tangent of 50. So if you could please write down cosine of 50 equals, whether you have parentheses around the 50 or not doesn't really matter, sine of 50 degrees equals, and tangent of 50 degrees equals. We're just going to calculate those on our calculator in just a moment. But why don't we also set up statement 2? It wants us to find the cosine of 40 degrees, the sine of 40 degrees, and the tangent of 40 degrees. So pause this video for a moment and find all 6 of those values using your calculator, and then come back to this video. Welcome back, Geometry. If your answers vary from my answers, for example, in the hundredths place, it's fine. The bigger takeaway that I want you to notice here is something that we first pointed out in our trig packets on page 1. I'd like you to notice that the sine of 50 is equal to the cosine of 40. They were both 0.77 in value, and the cosine of 50 was equal to the sine of 40. They were both 0.64 in value. So in the space for number 3, can you please write down the following? That the cosine of 50 degrees was the same thing as the sine of 40 degrees, my two acute angles. And the reverse was also true. So starting now with my second statement, the cosine of 40 was 0.77. The cosine of 40 degrees, 0.77, was equal to the sine of 50 degrees, which was also 0.77. When we look at the tangent values, however, that's not the relationship between the tangent of 50 and the tangent of 40. They're actually each other's reciprocal. Reciprocal would be 1 over that number. So for example, the tangent of 50 is equal to 1 divided by the tangent of 40. And the reverse is true. The tangent of 40 is equal to 1 divided by tangent of 50. That would be the relationship between the tangent of my two angles. We've already calculated the value of z on the page before. So let's move on down to the bottom of this page where it says solve these triangles. On this page, you should be able to solve for x and y in both of these triangles already. So I'd like you to pause this video, work out the two problems, and then come back to this video and see how you did. Welcome back, Geometry. Let's take a look at number 2 for a moment. Angle F is a right angle. That's very important, or we could not use our trig. And I know this because 42 degrees plus 48 degrees is equal to 90 degrees. And since a triangle adds up to 180, I know that angle F is 90 degrees and is a right angle. So I can use my trig. And you could either do the sine of 48 like I did, or you could use the cosine of 42. So either setup would help you find the value of y, which is 5.2. So I'm on page 473 of our workbook, and we have 3 problems to do. There's not a lot of space to work out A, so why don't we just carve out some space for A. Perfect. So it says the measure of angle x is 90 degrees. So first off, let's sketch a right triangle. This is just a sketch. When we get done, it may not be drawn to scale, but we're just kind of getting an idea of what this triangle looks like. My 90-degree angle is X. It says that angle Y is 12 degrees. I'm going to make this angle up here then, Y, because it looks like my smaller angle. And I'm going to write a 12 in there. And then it says side XZ. Okay, so wait a second. That is telling me that this vertex is Z, and side XZ is 2. So that's the information that the problem has told me, and I need to find all the sides and all the angles. So first of all, finding angle Z is probably the easiest because I know that Z and Y are complementary. So to find the measure of angle Z, I'm simply going to do 90 minus 12, and when I do 90 minus 12, I get 78. So I'm going to write a 78 degree inside there. So now I'm left with finding two sides. And so I can use my trig functions on either the 78 degree angle or the 12 degree angle. You actually have a lot of options here. So I'm going to first solve for my x, y, and I'm going to use my 78 degree angle, which means I'm going to write a tangent equation, because xy is the opposite side from my 78 degree angle. So tangent of 78 degrees is equal to my xy, which I don't know, over my adjacent side, which would be my 2. That's my side touching my angle z. So I would multiply my 2 over, and 2 times tangent 78 should be equal to xy. I'm going to do the calculation on my calculator. Why don't you do that with me? 2 times tangent of 78, and we should get about 9.4. So 9.4 is the length of xy. I'm going to write that in here, 9.4. I'm only left with one more measurement to find. I know 2 of my sides. I don't know my hypotenuse. Let me change my pen color. So to find my hypotenuse, again, I could use the 12 degree angle or I could use the 78 degree angle. I'm going to switch this time and use the 12. This is my hypotenuse. I could write a sine equation using the 2, or I could write a cosine equation using the 9.4. So in this case, I'm going to use the 2, which is the opposite side from the 12, and I'm going to write a sine equation. So the sine of 12 degrees is its opposite side, which is 2, over the hypotenuse, which is the yz I don't know. So I'm going to multiply both sides by my yz. That's my variable. I need to get it up and out of my denominator. So I have yz equals 2 divided by sine 12. And so now I need to calculate my yz. Let's do 2 divided by the sine of 12 on our calculators. And we get 9.6 for our hypotenuse. Continuing on to the second problem, I know my other angle P is 30 degrees since my 60 and my 30 have to add up to 90. You can use both trig and also your 30, 60, 90 rules on this triangle. I'm going to do both to show you how you get a decimal answer when you use trig and you get the radical answer when you use our 30, 60, 90 rules. At this time, why don't you pick one method or the other and find the remaining 2 sides that are not labeled, and then come back to the video to check your answers. Welcome back. Let's first look at answers we get if we use trig. So looking at the green writing, I used cosine of 60 equals 4 over Pn to help me find my hypotenuse, which you can see my calculation. My hypotenuse is 8. I hope you also got 8. I then had quite a few options to find PQ, but I decided to use tangent of 60, and when I did that, I found that PQ was 6.93. These are the answers I get when I use trig. Under the dotted red line, you can see that I also showed my answers using 60, 30, 90 rules. Again, the hypotenuse is 8, but now you'll notice that the long side is 4 rad 3. Well, you'll find that if you put 4 times the square root of 3 into your calculator, you get 6.93. They're the same number, just one is in radical form and one is in decimal form. And so, depending on which form you want, you could use one or the other methods to solve this triangle. Let's take a look at C. It says the measure of angle K is 90 degrees. So let's draw a 90-degree triangle and put K on my 90-degree angle. It says angle L is 71. So I'm going to make this one my angle L because it looks larger than the one at the top. It says LM. Okay, so I know my other vertex is M. LM has a length of 20. That is my hypotenuse. And it would like me to solve for all my other sides and my angle M that are missing. So I'd like you to do that. Pause this video, find those missing parts, and then come back to the video and see how you did. Welcome back. You can see that in red, I solved for my other angle, my third angle, and got 19 degrees. Now, to find my two sides, I could use the 19 or the 71. I picked to use the 71-degree angle, so I used cosine to find KL. My KL side was 6.5 units, and I used sine to find MK. You can see in my work I used sine then to find my MK. If you have any questions on any of these three problems, please come to office hours so we can discuss. I'm on the summary page of this lesson, which is on page 475 of your books. And I just want to mention on this page that it doesn't matter the size of your triangle. So let's say I had a slightly smaller right triangle, but this was still a 25-degree angle. And then I had an even tinier right triangle, really tiny, but this was still a 25-degree angle. The sine, cosine, and tangent of 25 degrees is always the same number. So if you look up in the box above, you'll see that the cosine, which is adjacent divided by hypotenuse, the cosine of 25 is 0.96. It doesn't matter if it's in a big triangle, a medium triangle, or a small triangle. This is the bigger one, this is my medium one, and this is my small one. Cosine of 25 degrees will always give me the ratio of 0.96. In the big triangle, when I divide my B by C, my cosine of 25 degrees would be equal to B divided by C. In a larger triangle, B and C are just bigger numbers. In my medium triangle, the B and C would just be like medium-sized numbers. In my little tiny triangle, my B and C would be really small numbers. But when I divide them, every single time, I would get 0.906. The cosine of 25 degrees is the same, whether that 25-degree angle is in a small triangle, medium triangle, or a large triangle. The same is true for sine and tangent as well. Thank you very much.